Hi guys, so we're going to look at this short and simple topic called variations. This is most common in paper 1. So we're going to look at what we are supposed to know in this topic and what you're supposed to concentrate on. So now this topic called variations, you just need to know the types of variations. And by the way, variation is just simply a relationship between two or more variables. So now we've got types of variations. The first one, we have what we call direct variation. We have inverse variation. We have joint variation. We also have what we call partial variation. But in this tutorial, we only concentrate on the first three because this is where the questions are concentrated on. But at your own free time, you can take interest to look at partial variation. It's not that hard, but we look at what comes in past papers. So we're going to proceed. Let's start with the first one, direct variation, with an example. Right, direct variation. Now, direct variation is a type of variation where if one variable is increasing, the other variable will also increase. If one variable is decreasing, the other variable will also decrease. So it therefore has a general equation which is y is equal to kx, where y and k are the variables, or y and x are the variables, then k is called the constant of variation. So k is known as the constant of variation. Right. So that is our k. Then we're going to look at an example so that you can understand what direct variation is. Look at this example. Given that y varies directly with x, and so this should be and, so y is equal to 8, right, when x is equal to 6. Find k. Now k in this one is the constant of variation. So the k we're talking about is the constant of variation. Therefore, how can you go about this? So we can start. Let's start with the first one. How can we find the value of k? So we first have to come up with the equation. Now here we are saying y varies directly with x. So y varies directly with x. Instead of just writing x, you put the constant of variation first, then you now put the x. So y varies directly with x. Then they are telling us to say y is 8. Look at this. Y is equal to 8. Then when x is equal to 6. So while there is y, I'm going to put 8. Then here will be k. Then where there is x, I'm going to put 6. Then I'll say divided by 6. Even this side divided by 6. The 6 will go, the 6 will go. Here I'll say 2 into 8 is 4 times. 2 into 6 is 3 times. Therefore, the value of k will be equal to 4 over 3. So we found the value of k, which is the constant of variation. The other one, we are looking for the value of y when x is 3. So I'll write the equation that we have, which is y is equal to kx. Now, since we have the value of k, it will become y is equal to 4 over 3x. So we're trying to find the value of y when x is 3. So where there is x, we put 3. So the 3 and the 3 are going to cancel. Then the value of y will be equal to 4. So this is what we have on the value of y. So the value of y is equal to 4. Right. Then we look at the last part. The last part of the question, they're asking us to find x when y is 24. So the equation is as follows. Y is equal to 4 over 3 then x. So where there is y, if we put 24 here, we're going to say 24 is equal to 4. Let me just remove that. Right, so this should be 4 over 3 then where there is x, we put, well, it will maintain as x, so this will remain as x because we are trying to find the value of x. Then to remain with x and remove 4 over 3, we're going to multiply with the multiplicative inverse on both sides, which is 3 over 4. And this side, we're going to multiply 24 by 3 over 4. Then the 3 and the 3 will cancel, the 4 and the 4 will cancel. Then 4 into 4 is 1, 4 into 24 is 6. Then 3 times 6, that's 18. So therefore, the value of x is equal to 18. That is the value of x. So that is how you can go about questions on direct variation. Now we're going to proceed and look at questions on inverse variation. Now, what is an inverse variation? An inverse variation is a type of variation where if one variable is increasing, the other one is decreasing. And if one variable is decreasing, the other one is increasing. So that is it with inverse variation. Now, let me show you this example. We've been told to say, given that y varies inversely with x and y is equal to 4 when x is equal to 7, find the constant of variation. So the constant of variation we're trying to find is k there. So how can we find k, the constant of variation? So let me do the first part. So let me do a part here just on top. So I'll do the first part, part A, of the solutions for A. So here we're saying y varies inversely. So whenever we say inversely as x, you put a k on top, then the x down. So this is what it means when we look at inversely. Then we've been told to say y is 4. So where there is y, we put 4, and where there is x, we put 7. So that is our y, we put 4. Where there is x, we put 7. Here we'll say over 1, we cross multiply. Then our k will be equal to, what is 4 multiplied by 7? 4 multiplied by 7 is equal to 28. So our k is equal to 28. So we have found k, which is the constant of variation. Now in proceeding, we can now proceed to find the other one. So part B here, they want us to find the equation in the form of y is equal to k over x. So the equation in the form of y is equal to k over x. Now we already have the value of k, which is a constant. So this will become y is equal to, where there is k, I put 28, then over x. So whenever they ask you to find an equation, you just substitute in the value of k, then leave y and x as they are. We go to part C. They want us to find y if x is equal to 2. So what is the value of y if x is equal to 2? So using the equation in part B, which is y is equal to 28, since the variation k, since k is a constant, so it will maintain. Then they are telling us we need to find y. when x is equal to 2. So this will be 28 divided by 2. So this will become y is equal to 2 into 28. It goes there 14 times. So y will be equal to 14. So the value of y here will be equal to 14. So that is how best we can go about questions on inverse variation. We're going to proceed to look at what a partial variation is, or joint variation, and some examples. So a joint variation is a type of variation where we are dealing with more than two variables. In direct and inverse variation, we could only deal with either x and y or a and b, but in joint variation we're going to deal with more than two variables. It can be x, y, z, it can be p, q, r, it can be a, b, c. So now how do we go about this one? Follow me. So we have p varies jointly with q. So this is what I'm going to do. So for the first one, they're saying p varies jointly with q. So I'm going to say p varies jointly with q. But before I can write q, I first put a k, which is a constant. So I'll say kq and the square of r. The square of r means r squared. And p is 3. So look at the value of p is 3 when q is 2. So the value of q is equal to 2. Then r is 3. So the value of r is equal to 3. So we find the value of k. So I'll start. P is a 3. K I don't know. Then q is a 2. Then r is a 3. It will become 3 squared. So 3 is equal to k multiplied by 2 times 3 squared. 3 squared is 9. 2 times 9, that's 18. Then I'll say divide by 18. When this side, divide by 18. Okay, so that goes. Then k will be equal to 3 into 3 is 1. 3 into 18, that is a 6. So the value of k is equal to 1 over 6. Now that the value of k has been found, we go to the second one, which is asking us to find the equation connecting p, q, and r. Now remember, the initial equation is as follows. So the initial equation is p is equal to k q r squared. Now p is equal to, the value of k is 1 over 6, so I'll put 1 over 6. Then I'll leave out the q and r squared. So this is the equation that is connecting p, q, and r. Lastly, we are asked to find the value of r when p is 4 and q is equal to 1. So how do we find that? So we start. We have it as follows. So we are saying p is equal to 1 over 6, then q r squared. Then they've told us to say p is 4. Therefore we have 1 over 6 multiplied by our q is 1 multiplied by r squared, like that. Then we'll say we have a 4 here is equal to 1 on top. I multiply what is on top. 1 times r squared. I'll just have r squared. Then down I just have a 6. Then here I can say over 1 and cross multiply. 1 times r squared is r squared. And 4 times 6, that is 24. To get rid of r squared, I'll square root. Even this side I'll square root. That and that will go. Then r will be equal to, in front of the square root we put positive minus the root of 24. So this will remain as the final answer. Why? Because like I stated, this is a topic that comes in paper 1. Therefore you are not permitted to use the calculator, and you just have to leave it like that. So unless if you have perfect squares like the root of 9, the root of 36, the root of 49, those you can easily find their roots. So therefore we leave it like that. Then so that is it with joint variation. Now therefore I'm going to give you some work that you can try, just 2 questions that you can try out and see how best you can go about them. Okay, so the first question is as follows. So on the task, that is the first question, it is given that t is equal to k squared, where k is a constant of variation. Use the information given in the table to find the a value of k, b value of a, c values of b. So there's a table there that you can use. So we have v there and t. The second question is as follows. Given that y varies directly as x and inversely as the square of z, and that y is equal to 10 when x is equal to 32 and z is equal to 4. Find a value of k, b y when x is equal to 20 and z when x is equal to 20 and z is equal to 5. Find z when x is equal to 9 and y is equal to 5. Alright.